Okay, so today we will be covering Ohm's law, that guy. I took these from some notes I took earlier, and then I found some basic problems we can solve. I realize this is probably not going to be the most indicative one after I wrote it down, but we'll do all of those. Just do a quick refresher of what Ohm's law is and how to calculate them. Then later in the video I'm gonna take the breadboard and we're gonna actually take some resistors and LEDs and do some measurements and do some of these calculations on a real circuit. And I'm expecting those to look slightly different from what we see here. I don't think they're going to be that precise. I think we're going to get some decimal values. So I'll have a calculator ready on my laptop here. Let me actually just grab it. Calculator, because I'm not going to do the arithmetic in my head. Okay, so let's do the first one. So we have voltage equals current times resistance. So this is a very simple formula, and with some basic algebra I'm pretty sure we can calculate all of these fairly quickly. So let's start with this one. I need to reach around this tripod, which is incredibly uncomfortable. Let's do that. Move up a bit. So let's start with this one. So we will have R is equal to, wait, let's start like this. So we have voltage, so 1 is equal to IR, so 1R. So just R. So it's just equal to 1. Yeah, like I said, one's not the most indicative. Maybe I can look for another problem here that will be, but yeah. Okay, next up is V is equal to 20 times 0.5, so that I can do in my head. V is equal to 10. So we have 10 volts if our resistance is 20 and our current is 0.5. So this will obviously be ohms, that'll be volts, and this will be amperes. So in this case we have 10 volts for 20 ohms resistance and 0.5 amperes. Then this will be, again, V is equal to 1 times 2, so it's just V is equal to 2. So this will be for 1 volt, 2 ohms resistance, we get, oh wait, I made a mistake there. So V equals IR, so it is 1 is equal to I2, so this will be 0.5 is equal to I, so I is equal to 0.5, so half a ampere for if we have I times 1 volt divided by 2 ohms of resistance. Okay, that's fairly basic. I had to pull up some old notes for this, but I think V equals IR is fairly easy to remember. But let's apply it, see if it's as easy to in the real world as it is on here. Maybe I'll keep this piece of paper handy, and let's get this hooked up. So I'll need some power here. We can put that there, and then that there, get that in there, don't even know, I should probably not put too much current. I'm gonna start with 1 volt, and let's see what that ends up measuring. I'm not gonna turn it on just yet. Let's see, I have let's try and get I think the resistance of one of these. Could be a good first thing. Now, if I remember correctly, this is the long one's the positive side. There's also something to do with some LEDs have like a little notch. Let's see if we can see it from above. Yeah, it's not really visible on this one. There's like a slight one you can see if I make it shimmer like that. So let's put that in there. So this side's the positive side. So I'm gonna grab another red one here, link it to this, link it there. Oh, maybe I should explain. I already know how breadboards work, so maybe I should just explain that quickly, what's going on inside there. So breadboard has, for the holes, has wires that go this way. That's where I've hooked up the positive and the negative. Then for these going vertically, there are just wires going up like that. So if I connect something here and I connect something here, they are connected to the same wire. So in that case, what I've done is I will connect the LED there and there, and then I will connect that side to positive and this side to negative, and then that gets me a circuit. And then I will have to put one of these resistors in there as well. So we'll put that, maybe I'll go from, this is not technically correct diagram, but maybe I'll put a resistor across here, and then this one goes there, and then it goes back there through the resistor. I think the resistor goes on the positive side, so I'll do it on the other side. So let's do this rather, but that should show how that works. So it does have this in the middle. There's like a groove there. That means that side's not connected. So there's like a empty bit here, and then there's more lines here for this side. So that'll be like that. So those are lines there, those are lines there. Okay. Hope that makes sense. Put in the comments if it doesn't. I'll try and explain it better in another video. Maybe I can go into detail on that. So I'm actually, yeah, let's leave it like this. But I'm gonna take the resistor back on this side, so it's more aligned there. So, man, look at this, it's all bent up. This makes it difficult to get in. I don't think these are the best breadboards, so getting the pins in there can be quite difficult. So I want to connect that one from there to there, and then we'll make it clear that goes to the positive line, and then I need a black one here, and that can go straight from there to ground. Minus is sometimes called ground. I don't really know why, so if I use ground or negative, they're interchangeable. Let me turn this so you can see the hookup. So I have this going to the positive, it connects to a resistor it goes to the positive of the LED on that side. Then this goes to the negative side, to negative here. Whether I put it in here or here doesn't make sense. I've put these across so that they're connected, so it doesn't matter too much. Now let's see if I turn this on. Nothing. Yeah, nothing. Maybe this is the wrong way around. Let's see. Nope. Not it. Okay, that's wonderful. Let's see if let's start testing. I have a multimeter here. See what's going on. So I'll turn this on to measure resistance. And well, let's actually just measure the voltage here on DC. I think if I go there, I should get 1 volt exactly. Maybe this should be slightly more visible. Put it over here. Here you can see what I'm measuring. So all I did there is I'm measuring if I'm actually getting power in here. So coming in on the red and the black is exactly 1 volt. Man, is again exactly 1 volt. 1.0. Then maybe that's part of the problem with this resistor. Let's go up to 5 volts for this. Let's see. Get exactly 5 volts on there. So there the light came on. So that was the case. My resistor is probably quite strong. So let's see if I can see the voltage from the ground this side. Now I made these little things so I can measure this easier. So I want to see what voltage I get across this guy. Is it measurable? No, so I got 3.27. So if we do the calculations again, so volts across the resistor is, what was it, 3.27? Remember? 3.27. 3.27. Then the voltage across the LED let me know if I'm measuring this incorrectly, is 1.76, so it does drop 1.76. So what if I go, what am I going to get if I go from this wire across to the other side there? Not getting a good connection there. Let's get my other pin. Let's put it in there. I want to measure you. Put that in there and actually measure what that says versus what we get there. So this is a measuring, this comes in on the positive side, just exiting the LED and checking what I'm getting there. So let's see what these two give me. 5 volts. So I'm guessing what's happening is I'm measuring directly what's coming in there. So you have to measure across these to see what they get. So There I get 5 again. So this is something I don't quite know, is how to properly measure what my resistance is behind my resistor and the LED. But I did get 1.7 there. Let's see if I can get resistance, and maybe I can get my current that way. So I V that on the LED. So I'm going to start with getting the LED current flowing across the LED. So let's see what resistance I get there. Only ohms. I'm not getting anything there. Try again. Definitely not a 0 ohm. Do I need to select? Ohms. Ohms. That doesn't work. Okay, so I actually don't know how I'm meant to measure that. Do I need to turn off the power there and then measure that? Like this. I don't actually know. Let's Google it. See if we find something. Okay, how to measure resistance over LED? Directly, okay, let me read out loud. Measuring the resistance of an LED directly with a multimeter is not straightforward because LEDs are non-linear devices and the resistance changes with voltage and current. Instead, you can measure the voltage drop across the LED at a specific current and calculate the equivalent resistance in ohms. Okay, so I need to do this differently. So you can't just measure across there. Today I learned the whole point of this. So I need to somehow figure out what my voltage drop there is. So I can see, oh goodness, that's not a lot. So what I'm seeing on my power supply is 0 amps, 0 watts. So I'm guessing this circuit is drawing extremely little power. So let's just do the resistor for this video. I'm not going to keep this going much longer, and then we can do an LED maybe next time and see the voltage drop across a few LEDs, and I'll in the meantime figure out how can I actually measure the voltage drop from the LED. Maybe if I get a few, but let's see if I can see the resistance in ohms across this guy. Probably need to turn this off, pull out this guy there, and see. I might need to turn it off, back on again. Let's see. Hey, there we go. I'm getting, I think this is a 10K. So this is 9.80 across that thing. So the resistance was 9.80 again. 9.80 ohms. That's volts. So V equals IR was our calculation. Let's calculate what this is. So V is equal to 3.27 is equal to I times 9.80, and we should be able to find this is going to be a very low number. Like I said, this doesn't even register on my power supply, so this is going to be very low. So let's do that on a calculator. I will type in, this will be, so I need to obviously carry that over to that side, and I'll just divide both sides by 9.8, so the answer will be given if I do 3.27 divided by 9.80 is equal to my current. So this will be 3.27 divided by 9.80 is equal to, yeah, small, 0.3337 watts. So yeah, there you go. Oh, excuse me, that was off to the side. So I just did the 3.27 divided by 9.8 is equal to 0.3337. And yeah, that is a bit of Ohm's law and in practice. And we learned that an LED can't be measured directly, can't measure its resistance directly. You have to measure the voltage drop. So I think next time we can do a quick LED thing. I will set up beforehand a string of LEDs, make sure they turn on and that I have the resistor set up correctly, and we can see what the voltage drop is from there. And then I'm going to maybe tackle one new component, these guys, the capacitor. So we're gonna actually figure out what they do, how they work. I'm not gonna do switches now. I'll maybe also, as part of that video, look up what capacitors and inductors have in common. I think they serve similar purposes, but we'll figure that out together. Anyway, this video has been dragging on for too long already. See you in the next one. Oh, and like and subscribe.